Hi guys, we've been doing a lot with logs lately, and this last section in chapter 7 has a different approach on logs. It talks about base E and what we call natural logarithms. A natural logarithms with base E are what we call natural logarithms. And I'm sure you're thinking, what the heck is base E? So think about this. Think about pi. Pi is an irrational number. You know the approximation is 3.14159, goes on forever and ever. E is also an irrational number. The number E is approximately 2.718, and it keeps going. In terms of when do you use E? If you are going into engineering, if you are going to science, E is a natural number that's used all the time. Kind of like we only see pi when we're doing things with circles, all those things. E is something that is used in applications with science and engineering all the time. It is also used very heavily in calculus. So if you're intending on going there, onward to calculus, you will use it. Now, so what this means is, instead of writing something log base E, you can use the term ln. You should be able to see, if you pull up your calculator, pull mine up really quick, that ln button is right there next to the number 4 below the log. So we will be using that a lot as we go through this with our calculator. Okay, so we use this abbreviation ln, maybe, there we go, ln without a base to mean natural log. I don't know why it's not NL, but that's how we do it. Now, the natural log is the inverse of the exponential with base E. Just like a normal log is an inverse of an exponential with whatever its given base is, a natural log is the inverse of an exponential with base E. And all the properties we already know apply to this new concept called natural logs. So it's really not completely new and different. It's like an extension of what we already know. So that's good. Okay, in terms of evaluating things, when we're evaluating these, we can very easily type these into our calculator. So if it says ln of e to the -4th, I can hit ln. E is above the ln. Well, E's there twice. You can either use above ln or above the division sign. So I can hit second ln, and it automatically prompts me for an exponent. So I can type in -4. Okay, and as an answer, I just get -4. Now, why is that? Well, like I told you, ln and base E are inverses. So those two things counteract, they cancel each other out, so to speak. Okay, same thing, I can go to the next one. When it says evaluating and it's all numeric, this is really just typing it in. ln of 1, I can go to ln, type in 1. It tells me it's 0. Okay, same thing for the next one. I can say E, so I can hit second ln, and then to the ln of 7. It tells me it's 7. Again, the reason why that happens is because that ln and that E cancel each other out. This is just a 7. And then I have ln of 1 over e to the 3rd. Same thing, I can type in ln of 1 divided by e to the 3rd. And I get -3. Now that shouldn't be surprising to you, because 1 over e to the 3rd is the same thing as e to the -3rd, and that ln and e cancel each other out. So the evaluating is no problem, just like when we did basic evaluating with normal base 10 or other base logs. This was not an issue either. Now, in terms of the solving, all the log properties you know work. Okay, so when you see anything with equations, the first thing you want to do is apply any properties that you possibly can. Okay, so with this first one, if I have -4 ln of 2x equals -26, okay, I can't do anything with this in terms of deciding is this a canceling or a rewrite situation until I can get that ln by itself. So the first thing I'm going to do is divide both sides by -4. So I have the ln of 2x equals. You can either tell me 6.5 if you want to, since that's a decimal, or you can tell me 13 over 2. I'll probably keep it in fractions. Now, at this point, just like it would normally be in a basic base 10 log. The deal with this is there's only one log, one ln, so I have to do a rewrite. Now the question is, what's the base? Well, you gotta remember, ln is base e, so if I rewrite this, this is going to be e to the 13 over 2 equals 2x. Okay, well, all my rules about these decimals to four place values still work, meaning if I need to find e to the 13 over 2, well, maybe I'm not going to. Okay, I hit e, and I put in 13 divided by 2. And it's going to give me a value. It's a large value. We're going to deal with it. I'm going to say that's 665. 1416. Okay, then I'm going to go from there like I always do with equations and divide by 2. And I'm going to tell you that x is 332.5708. Now, there is this idea of checking with these because this is at the heart, this is a log equation. So I need to make sure when I'm taking the log or the ln of, because ln is just a version of log, is positive. So if I plug that in, this does check out. All is good. We're good to go. Okay, when I look at that second one again, try to apply the properties first. Okay, I see two logs that are connected by addition. You know that I condense them to 1 by multiplying, so that gives me ln to the 6x squared, or ln of 6x squared, I'm sorry. Okay, from here I have to look, is this a canceling or is this a rewrite situation? Well, there's only one single log. This is a rewrite. So I say it's e to the 9th equals 6x squared. Well, again, at this point, e to the 9th is something I'm typing into my calculator. When I did that, I got 8103.0839. Okay, then you know how to solve this. You know that we would then divide both sides by 6. So I have 1350.5140 if I round it right. And then I would take the square root. Now, when I do that, when I take the square root of 1350.5140, technically I get a positive, or a negative version. So technically, this answer should be either plus or minus 36.7493. But again, I've got to check my answers. So when I plug this in, the positive one will be fine. But if I plug this in, this negative one's no good. So really, the only answer that actually works is the positive 36.7493. Remember, at the heart of this, if there's ever an equation that is a log equation fundamentally, whether it's a normal log log or an ln log, a natural log, you have to check that. Okay? And then that last one you see there, again, there's properties to combine on the left-hand side. I can condense these into one by using my properties of exponents. This says addition, so this means I'm going to multiply. So I'm going to have the ln of 20x squared equals the ln of 5. Now, this one's a little bit different than the other two. This one has an ln, or a natural log, on both sides. We know that when we have a natural log on both sides, that's a canceling situation. So this cancels. I get 20x squared equals 5, and then I can go from there. Divide by 20. X squared equals 1/4, and then take the square root. Now again, taking the square root of something generates a positive and a negative, so technically I get plus or minus 1/2. But I look at this, and when I plug that in, that negative will not work. So really this answer is just positive 1/2, 4.5. Okay? Hopefully we're so far so good. Now, the 2 at the bottom there. These are no longer log equations. These are exponential equations. And again, I can tell the difference because I don't see that basic log log or ln. I see the variable in the exponent. So we are going to treat these just like we did yesterday. We're going to get the exponential by itself, and then we're going to go from there. This is what I mean. So if I look at the first one, if I look at C, the exponential part is e to the b plus 3. That means I need to get rid of that 10. So I'm going to subtract 10 from both sides. So I had e to the b plus 3 equals 17. Now, this is that idea that we talked about yesterday where we could log both sides. But the thing is, since we're dealing with base e, we don't want to log both sides. We want to ln both sides. So I'm going to take the ln, or the natural log of those sides. But after I do that, everything works like yesterday, meaning this exponent's allowed to go in front. So really I have b plus 3 ln of e equals ln of 17. I divide both sides by the ln of e, just like we talked about yesterday. Again, that's a calculator thing for me. So I can go ln of 17, closing those parentheses, divided by ln of e. Now, the e that we've been using before was above ln. If you look above the division sign, there's an e that doesn't have an exponent. It really doesn't matter which one you use, but if you use the other one, the exponent would be 1. Okay, so I get b plus 3. I didn't look at that before that went away. b plus 3 equals 2.88, or 2.8332. 2.8332. Then you have solve from here. We're home free. We subtract 3 from both sides. We get b to be negative 0.1668. Again, there's nothing to check when it's an exponential. We only have to check things that are log functions at the heart. Okay, and this last one, so my exponential piece is e to the p minus 2. I've got to isolate it. So my first thing to do is add 2 to both sides. So I have negative 8 e to the p minus 2 equals negative 69. Then I have to divide by negative 8 because this exponential piece is still not by itself. Now when I do that, I can leave it as 8.625, or I can leave it as a fraction. I'm going to leave it as a fraction. So I have e to the p minus 2 equals, it ends up just being positive 69 over 8. Now again, we are at the point where the exponential is by itself. So this is where we log it, log both sides, or ln both sides because it's base e. And then everything we did yesterday applies. That exponent comes in front. Okay, we try to get the ln's together by dividing both sides by the ln of e. Again, that becomes a calculator thing for us. So I'm typing in ln of 69 divided by 8 divided by the ln of e. So I get p minus 2 equals 2.1547. I add 2 to both sides. So I end up with p being 4.1547. Okay, now at this point, there's nothing to check because this is an exponential. Okay, if you look on the back, there are 6 of these. I'd like you to pause the video for a second and try these. All right, guys, let's check these real quick. If you look at the first one, the reason why positive and negative both work is because when you're plugging this in, you get x squared. You're plugging it as x squared, so this will work out as positive and negative. 2. Again, combine by division, rewrite, go from there. And number 3. 3 became a quadratic. I didn't show how I solved the quadratic, but you can either factor or use quadratic formula. Negative 4 does not work, even though you get it as an answer. 2 is your only answer there. Okay, and then on the bottom, isolate that exponential. ln both sides, take the natural log of both sides, and then apply those properties. So there's 4 and 5. And here's my 6. Okay, guys, hopefully this makes sense. Hopefully we're in a good place. The sub has the worksheet for you. So thanks, guys. Have a good weekend.